Okay, here we're taking a look at applying the law of sines in a somewhat different way. Whereas on the previous examples, we had two angles and could automatically figure out the third angle by the fact that triangles have an angle sum of 180 degrees. This time we only have one of the angles and two of the sides. And this can lead us to a problem that's referred to as the ambiguous case. So in the end on this, we're going to want to be figuring out an angle by using an inverse sine. Now, as you'll recall, inverse sines only give you answers that are between negative pi over 2 and pi over 2. And because we're going to have positive angles, that means between 0 and pi over 2, or since we'll do this in degrees, 0 and 90. Now, that means that the angle we're looking for, it won't ever catch for us an obtuse angle. It'll only ever give us acute angles. So we've got to keep that in mind as we go along here. All right? So, as it says here, we're going to consider our triangle where we've got angle B given, and we've got the side adjacent to B, and the side A given, and then the side opposite the angle, and little b is given. And it's often helpful for me, at least, because I'm a very visual person, to think about trying to construct the triangle and see what's actually possible. So if you look here at this first case, this is when the height, the h that we calculated, or the height, is going to turn out to be greater than the side B. I'll write it like that. And as you can see, the problem we run into there is that the perpendicular height being longer than the side that you want means that you can't actually make the triangle. So case 1 is going to actually have for us no solution. Okay. Then if you extend things down just a little bit more and you hit exactly long enough here, so you've got your B actually being equal to your H, then you're going to have exactly one solution possible. All right. Now, the next case that we have here is the one that's difficult. This is what's referred to as the ambiguous case. And so if you set up your, according to this picture here, your sine B over B, and say that it's equal to the sine A over A, you're actually going to know values for the B, the big B, the little b, the little a, and you'll have to then figure out that sine A is going to be equal to A sine B divided by B, and take the inverse sine of that stuff over there in order to see what you get. And remembering that inverse sines will only ever give us acute angles, that means that the answer that you'll get out of this is going to be the bigger triangle here that has an acute angle for A. Of course, in this case, it makes reference to it as A prime, right? Okay, so the nice thing that happens then is that the other solution that we might get, that I'll draw in blue here, that other solution has to have the side B having the same length as it did before. And that means that our triangle inside here is an isosceles triangle, and that means that these two acute angles have to be the same angle, which tells us that this solution A here is going to be equal to 180 minus that A prime. Okay, we will see an example in a moment that will clear that up a little bit. Then the final case that we've got here is when, oh, I'm sorry, I forgot to write this down. H is less than your B is less than your A. The final case here is when you get your B being greater than or equal to your A. In that case, if you tried to swing this piece across here, when it tried to hit on the other side, it would make angle B not actually work out. So in that case, that means there's only one way to make this happen, the case where C is an obtuse angle. And so this takes us back to one solution again. Whereas you have two possible solutions here for the case 3.